going to do here is do a quick review of what we learned last term in third term and how we're going to apply that this time. We're going to be looking at solving equations by factoring, the quadratic formula, and completing the square, which involves imaginary numbers, real numbers, square roots, factoring, all of that. So we're going to do today, we're going to spend the day, we're going to do a quick review. So these are examples that help you do your review in class. I'm going to start with the square root of 18. Whenever we're finding the square root of 18, we're looking for perfect squares. What is a factor of 18 that is a perfect square? That's going to be 9 times 2. I know the square root of 18, it's 3. So this answer is 3 square roots of 2. Then I have the square root of negative 100 right here. When I look at the square root of negative 100, I know that that's actually a perfect square. I know the square root of 100, but this is also times negative 1. So let's go back and remember. The square root of 100 is 10, and the square root of negative 1 is I. So just a reminder, if you have a negative underneath a square root, you're going to have an imaginary number, and you're going to have to remember your I. So then I have the square root of negative 24. The square root of negative 24, we have a perfect square. What is a factor that is a perfect square? That's 4. But I also have negative 1. And then 4 times 6 is 24. So when I look at what I know the square root of, I know the square root of 4, and I know the square root of negative 1. So this answer is actually going to be 4i square roots of 6. 4i square roots of 6. If it has a negative underneath that square root, you cannot forget the I. Then in the second, number 4, in this next one, I have the square root of negative 63. The square root of negative 63. So I'm going to come over here and do that one. So we have, this is, the perfect square is 9. I also have that negative 1. 9 times 7 is 63. So I know the square root of 9, that's 3. The square root of negative 1 is I. And then you have the square root of 7. So I carry over this 2/3. That just carries over. It's outside. It stays outside. Then I take the square root. 3i square roots of 7. 3i square roots of 7. And then you're going to multiply these two numbers outside, and actually the 3's will cancel. So my final answer is 2i square roots of 7. So this just kind of brings back, breaking them down, and when you have an imaginary number or a complex number. Number 5, we're going to break down what we can. 3 square roots of 6, 6 doesn't have a perfect square. In 24, we have a perfect square. This is 4 times 6. I know the square root of 4. In 54, we have a perfect square. This is 9 times 6. I know the square root of 9. So when we rewrite what we have down here, we end up with 3 square roots of 6 plus 2 times 5 is 10 square roots of 6 minus 3 times 4 is 12 square roots of 6. So each one of these has the radicand of 6. We broke each one of them down and we took that square root. The square root of 4 is 2, the square root of 9 is 3. So 2 times 5 is 10. 3 times 4 is 12. Since all of them have that same square root, that radicand, the same square root of 6, we add the coefficients. So when I go to add, here's what I add. 3 plus 10 minus 12 is going to be 1. So this is going to end up being 1 square root of 6. You can only multiply and simplify in underneath the radical. You cannot add or subtract. So that kind of touches base with the basic radicals.